Oh, there we go. We're live. Hello, my name's John Stevenson, and welcome to another Clojure study group. This is Clojure study group number 22, and this week we're going to look at. Oops. Oh, there we go. Let's get rid of that. And we're going to look at how to learn Clojure. Some of the tools we can use to use Clojure, learn Clojure, and one of the simplest ones is called Maria.cloud. And it's really designed for people who have done no coding whatsoever, no programming whatsoever. And we're going to see how that works, and we're going to modify the curriculum and hopefully create, or at least start creating, something for an event that we run in London called ClojureBridge London, which is reaching out and supporting women and underrepresented groups and helping them get into software development and the industry as well. We have our next event in May, so hopefully we shall have Maria.cloud added to the content that we already do for that as well. So let's go and have a look at Maria.cloud. So it is just Maria.cloud or www.maria.cloud. And it's a very simple user interface. It's basically got this Learn Clojure with Shapes curriculum, and it's got some examples and discussions about why this was created in the first place, why this project was created in the first place. But in summary, it is just to help people engage, and they term it as having a conversation with your computer, which I think it makes it easier for beginners to start understanding programming if you frame it as, well, we're just having a conversation with a computer. We're telling the computer to do things for us, and we can see what it's doing because we're getting it to do very visual things. The classic way of doing this used to be with something called turtles, and you used to have a turtle that you would move around. So you'd have just an image of a turtle, and it would move around the screen, and as it moved, it would draw a little line behind it as well, so you could see where it's going. So you could get the turtle to draw shapes as it moves, and it kind of introduces you to basic commands and also kind of how to program. If you wanted to create it it's like multiple shapes, you could get it to repeat lines over and over again, so you can introduce it to things like for conditions and so on. If you have any questions or suggestions about what you'd like to see inside Maria.cloud, then please let me know. We are going to be developing this over the next couple of weeks, so if you have any things that you think would be great to add, then please let me know as we go through this. So let's go, and my journey begins here. So let's begin our journey there with new shapes. So it starts off nice and friendly, and you can see that it's got some descriptions, and then it's got these white areas where it's got some code in there. And what you may not realize first is you can go in and edit this. Oops. There we go. So it's a live document. It's meant to be a kind of live document, so students can go in and edit this and go and play around with this as well. And we'll set this up with Github gists, so we can actually save our own specific version of this. It'll cache the changes for a while, but what we'll do is we'll set it up properly so we can save these things. So we can go and create new pages that we can go in and save in our own under our own Git account. But let's come back to that in a moment. So you can go in, and it's basically saying you can use either Control Enter or Command Enter if you're on a Mac, and press the button, and we get a circle. There we go. And if we go in and change the numbers, she gets a bigger circle. There we do. There we go. And a smaller circle. Oops. So it's pretty easy to engage with. It's fairly easy because it's got this fast feedback of in a very visual nature. Then it's very easy for somebody who's never done any programming before to see, okay, I'm calling a circle, It's got size 5. It's drawn me a circle. So that's basically the kind of the premise here. So we can go in and create new lines as well. So if I go in and press enter, if I press enter on a blank line, then I get an opportunity to do some more code, and it's also got some like auto completion kind of type auto suggestions stuff there as well. So if I start typing things in, I've got square. Oh yeah, I can do a square. And then obviously if I do 34, that's probably going to cause an error. Boom. Oh no, it works. There we go. I expected an XY thing there. There is a, oh yeah, here we go. So there is a what is that kind of explains what things are and how to call them. Yeah, so, oh, it's a function. That doesn't really tell me a huge amount. Oh yeah, with an input that returns an output. Okay. Boom, boom, boom. Oh yeah, and that's square 50. Here we go. And then if you get errors, then it shows you a different color for the errors. It kind of shows you a very clear visual clue that something's gone wrong, and it's saying that, oh yeah, it's saying that yeah, it says it needs a different number of arguments. Now that's quite different to what you would get with Clojure. If you were running it on the JVM, you get a very, and even on the on JavaScript platform, you'd get quite a different kind of error. This is a nice, very simple, easily understandable error by people who are just starting programming, which is very nice. That's what we need. And yes, an important thing here is that don't worry, errors happen to everybody programming. Stay positive. That's always a good piece of advice. Programming can be very frustrating sometimes, especially when you're not having a good day or a good week. And yeah, even the best programmers can completely mess up what they're doing, as I did this week. I won't go into that. There we go. And so, yeah, so I can go in and it needs a different number of arguments. So if I go and press enter, then it clears the arguments there. And if I do circle, so it's quite responsive. So it's yeah, it's updating the page straight away. It's showing us information. Oh, it's even telling us like radius must be a number as well. So it's telling us that yeah, we need an argument and it needs to be a number. So that's quite cool. What else we got? Oh yeah, this is what I was looking for. So if you want to understand what the function actually does, then we can go in and call doc, just like you would do in normal Clojure stuff. So in the in the Clojure.REPL namespace, there's the doc function in Clojure, which will basically return the doc string that every function should have to describe what the function does, and also show you what arguments it's going to take as well. And again, this is yeah. So this is the normal Clojure. So you get this in Clojure itself, but the what is, which was further up, that's been added by Maria.cloud, just to give you or to give the beginners like a kind of a simplified description of something. So if I do it's the same kind of thing. So it's just giving a very general kind of description of what something is. If I put a number there, still some experimenting to do with this, but let's see. Oh yeah, there we go. So we've got a number. So it's kind of talking about what something is, rather than what something does. So the doc is what something does, and the what is what something is. So if I do I am a string, which it is a string. So double quotes enclosure is a string. Oh, and it's a string. There we go. So it's a nice kind of way to describe the different kind of types that we have in Clojure. There we go. Any questions so far? No. So there's quite a bit in this. I'm not going to go through everything. I think the kind of really interesting aspects are the visual nature of things, and we can colorize aspects of that. Ooh, I wonder if you can do fill and so no, it's probably fill, but what's the other one? So bound, you can do borders around it as well. So, oh yeah, so it's, oops, sorry, I'm getting carried away now. Yeah, so we've got a function here as an argument to another function as well. So that's an important kind of Clojure concept to teach people. And so because this function is going to evaluate to a value, then that value can then be used by this function as an argument. And then this function is just going to return a value, in this case, a nice blue square. So it's yeah, so it's again, it's simple steps to kind of help introduce the important parts of programming in Clojure. And here we've got yeah, even more kind of like nested functions. So we're introducing multiplication here. So the result of evaluating this function is passed into this rectangle function as an argument, and the result of that calling rectangle is passed into colorize as another argument as well. So I might kind of explicitly kind of put some like little tech boxes in here as well. See if you can do some notes in there, so you can just kind of show, kind of just help people understand what concepts they're learning and give them a sense of achievement as they're going through. Plus, it'll help them if they want to move on to Clojure in a kind of standard environment. Then it'll help them understand these concepts and apply them. Oh, we can see color names as well, so they can see evaluate. So we can evaluate symbols, names, and we get a result as well. So this is an important concept for people to learn as well. So here, so this would be in normal Clojure, this would be a def color names, and it would be a vector of vectors, and each vector has a string and a color to represent yeah, a different color. So we can kind of go through here and yeah, very easily pull out colors from that. And yeah, and then we can also oh yeah, cool. And there's a lot more colors there we can go and look at. We can also go and look at colors named yellow. So we can just look at a subset of those colors as well. Again, this is an important aspect of Clojure. It's taking a data structure, usually have like one big data structure that we have, and we're taking that and we're transforming that, or just getting a piece of that data structure and shaping it so that we can actually have a more useful piece of information. So if we just get the colors named yellow, and then we could randomly get one of these to kind of cycle through, like changing, if we wanted to animate the changing of a color of a shape, then we could just like iterate through just the yellow colors very easily, and that would be a nice simplification of the data, which makes our algorithm to iterate through the color names quite simple as well. Yeah, we're doing. What else have we got? Just pick colors. Let's have a look. Oh, there we go. Ooh. Purple. Specific. It might be too specific. Oh, we got two different purples. There we go. Medium purple. Okay. Let's see. Oh, what's the edit to quick start? So links, you need to be able to, if you want to click a link, you have to click on it and then click on the actual link that pop up, I think. Oh, there we go. That'll be quite good. Oh yeah, so this basically explains how to use this in more detail, and you can do kind of structural editing as well in this. Is that what that's showing? What's that showing? Oh, okay. So this is showing you selecting, so you can kind of select on elements of a data structure. And you can move parentheses as well, which is quite cool. Oh yeah, so if you wanted to do what we call slurp in there, what is that? That's control right arrow. Oh no, that didn't quite do that. What's oh, shift control. Oops, I misread. Let's see. Shift control. Oh, that's barfed. Oh, yeah, there we go. I did left arrow instead of right arrow. Okay, so I can slurp and barf. So I can basically pull in or throw out the structure and keep. So I'm not breaking this vectors. I'm moving things out, and I'm not breaking the outer parentheses as well. So you can do some simple what we call structured editing, so moving the code around without worrying about breaking the parentheses, the parens, without worrying about breaking vectors and maps and so on. I can keep the structure of the code together while still moving things around and still refactoring, still editing our code. There we go. That's quite nice. And we can use. Okay, there we go. Okay, yeah. So we want to evaluate the whole block. So if I just did Control Enter there. Oh no, it does the whole thing. There we go. Yeah. So it's oh yeah, so you can evaluate the whole thing, and you can wherever you are inside here, just do Control Shift and Enter, and it will evaluate the whole thing. That's quite nice. It saves you going to the end each time. Yeah. Oh, boom, boom, boom. There's a control bar. Which key? I'm not quite sure how that works. Oh, but there's this commands thing up here as well, so you can go and search through commands. So we've got redo, which is quite handy, and undo. So Control Z and Control Shift Z. We can paste stuff in there, so that's quite nice. Oh yeah, slurp forward and barf forward. There we go. So the command palette, yeah, it gives you a nice way to search through commands if you do find any bugs. And I think that just leaves. Oh yeah, it just signs me out. There we go. I think I must be already signed in. Yeah, so if somebody does have a little bit of programming, or they're fairly confident that we can kind of point them to doing some simple things with that, especially if we do some more complex stuff, it might be useful, especially the slurping and barfing, and certainly I'll point this to our coaches so they can understand how to do these things and show the students on their laptops how to do things like structural editing. No questions so far? Okay, I'll keep going. And so we've done simple, we've just done simple images, and we've changed then their colors. And we can also do layers of images. So if we wanted to do like more interesting pictures, and I think this is where we can kind of encourage the students to do something a bit more creative, is using layers, so they can actually draw like pictures and images that they find interesting. And yeah, let's see an example here. Oh, it's not my favorite colors there, but let's see. What's the, so we've got a square. Should we do a square of green? Change this purple. There we go. Does that look nicer? Using some Wimbledon colors there. It's a bit less bright. Let's see. Let's do, what do we do? 20. 60. Which that's interesting. So it's kind of we need to also look at where to position things, which I think, which is the next one. There we go. So they're all kind of like drawing things. If you don't specify a position, they're drawing things from the top corner by the looks of things. So that's top left corner is kind of 0.00. It looks like, and so then we can position things. Position things next to each other. And what we're doing here. So we're creating a circle which is green, and then we're basically using position as an offset, I think. So I guess that's 50 along, 25 down. I'm not sure. You kind of have to play with that a little bit, I think. So we can make the circle smaller. 10. Okie dokie. Oh, so yes, so that's, oh yeah, that's right, yes. So that's the 50, yeah, so 50 is on the x-axis, so from left to right, because the green circle is radius 25, so its diameter is going to be 50, so that's the point where that one intersects. And it's the radius is 25, so that's the point where that intersects as well. So this is position X and Y. I guess that probably did tell me in the text as well, but I didn't bother reading that specifically. Although I'm not sure it takes, I don't think it says that in the text, so I might need to add that. Which is X and Y. Of 0, 0. Oh yeah, I think it does say something like that, but there we go. This is a few. I wonder if we can add some styles to that. I'll do look at that later in a moment. Okay, so we can do other things there as well. So we could do, if we did 25, 25, it's going to put it in the middle of the other one, and let's make that 15 for now. I'm going to make that blue. There we go. Oh, there we go. So we got a circle within a circle. So I can create a couple of eyes, and we could go on and create a more complex shape. Oh, there we go. Yeah. So you can create some fun images. So here we've got a couple of triangles, which I guess is making the eyes for this funny face, and a white circle, which is the mouth, and then this aqua circle is the overall face there as well. So you can go in and create a whole bunch of interesting things around shapes. So I'm going to try and get my creative head on and think about what kind of shapes and what kind of things would be fun to do. I guess what could we do? Some ideas. Let's put some ideas down. So we could do a house. A house maybe with a garden. The sun up in the sky. That's getting quite quite advanced, I think. What else can we do? We do a cat. Oh, we could do a cat or a dog. I guess the cat, you could use the triangles for the cat's pointy ears. So you could do cat face. That would be quite cool. So I guess you would have to offset the you'd offset the position of the head, so you get the triangles in, and yeah, that could be quite fun. And see if there's any other things that we can do there. Oh, we can do bold. Can we do bold? There we go. We can make things bold. Can we make it italic as well? Oh, yeah, we go. Bold and italic. Cool. Just by the usual capital B, capital I. Oh, looks like we can include icons as well. And then what else can we do? Superpowers. Oh, so now this is quite good. So now we're getting onto kind of like the understanding some of the core Clojure functions like map. So we can go in and map a square. So this is going to, hopefully you've guessed what this is going to do. There we go. It's created a whole bunch of squares. So that's a nice way, nice visual way to show what's happening with map. So map is going to pass each of these numbers in turn to square, and obviously then it's going to draw a square, and we get those different squares on as a result. Oh, and then it's just asking us to do the same thing but with circle. I guess that's pretty easy to do. Let me just copy that. Oops. Do that. Press the wrong button. Oh, it's interesting. Oh, okay. I didn't notice this down at the bottom. There's actually right down the bottom. It's actually showing us the function signature. So here it's got CLJS core, which is Clojure, because this is all Clojure script rather than Clojure, but it's the same language. It's just Clojure that runs on the JavaScript virtual machine, whereas Clojure itself just runs on the Java virtual machine. So here we've got CLJS core, which is map, and the map function from that. So this is our namespace, CLJS core, right down the bottom left corner, and map is our namespace. And then these are the possible shapes of arguments that we can take. So we can just give it a function and a collection. So we were giving it square, if I can type. And then we were giving it 4, 8, 16, 32. That's not quite what we gave us, but that's close enough. There we go. And obviously we can do the same thing with circle. There we go. And that's just an exercise. So this is an exercise just to go and fill in the blank. There we go. Yeah. Oh, we're showing the different ways to use map. So we can map over 2 different sets of data. And oh, so yeah, so rectangle. Oh yeah, this is quite interesting because the rectangle is going to take. I think we do. We've just use this one. Oh, actually, make a new one. So press enter and then press enter again, and we can do doc rectangle. And that's just giving us a little pop-up thing, and then we can see what a rectangle takes. So we can see that rectangle is taking width and height. And so we need 2 values. So if we just passed it a single map, it wouldn't work because it would complain. So if we actually remove this, obviously, then that would be that would fail because we need height. We've got the width values because it's taking a value 10 here as the width, but then it doesn't have anywhere else to get the value from. So actually, this is quite useful to kind of show people that, yeah, like multiple arity. So showing rectangle is taking 2 2 arguments, but also you can get those arguments by having multiple data structures it's pulling from. So it's showing you that how map works when you've got more than one piece of data here. So we've got 2 pieces of data, and it's showing you that rectangle is going to take 10 from here and 10 from there, and then draw 1 rectangle, and then it's going to draw the second one from 10, 25, and so on and so on and so on. So we put that back and we get to our rectangles. So this is kind of showing you, in more detail how map is working. So if we click on map again, we get down here the description, the very basic description of map. And so we can see that in this third thing in the list of arguments we can give it, we're giving it a function which is rectangle, and we're giving it a collection 1 and collection 2. So this is our function, this is our collection 1, and this is our collection 2. And so it's taking an element from each, the first element first time, the second element of each the second time, and so on and so on, until there are no more things left in the in those collections. And we can also show how it deals with things when there's an uneven number of things in the map as well. I think this should just still draw exactly the same number. There we go. Yeah, so it draws the same, or actually, to make it a bit easier to understand, if we just removed 50 from there, it would still work, but we would lose one of our rectangles, because map is only going to work when it's going to stop whenever it reaches the end of whichever is the shorter collection. Okay, so that's a useful, interesting thing to kind of include. Yeah, I guess it leads on to discussions about, well, how's map know when to stop? Because we're not actually telling it, we're not actually giving it a condition on which to stop. It just knows that that it needs to stop when it gets to the end of a collection. There we go. Oh, there we go. Oh, that's the which key. Not sure how I made that appear then. Let me try that again. There we go. Oh, so if you hold, okay, right. If you hold Shift for long enough, it gives you this pop-up thing down the bottom, which gives you some, yeah. Oh, you can create a number list, paragraphs. Okay. New lines and stuff. Oh, and duplicate stuff. That's quite nice. Control S. Cool. Any questions? No questions? No. Okay. Okay, what are we doing now? Okay, there we go. And then we're just showing more variations of what we can do with map, which is quite cool. So just mapping. Oh, and we're introducing anonymous. Well, we're using like a function definition here. So we're just defining the function in line. So it's like it's a lambda function, and so we're just basically calling it straight away. So we're going to, instead of having a named function like square or circle before, then we're using an anonymous function. It's anonymous because we haven't got a name. We're defining a function here that we're just going to call in line, and it's going to take, that function is going to take a color from the collection, and it's going to pass that in here. So this is the argument. So we're going to colorize based on the different colors we get, It's going to create a circle 25, and we could also kind of round. I wonder if we've got round int in here. Round int. There we go. And then we need argument 25. There we go. Is that going to work? So hopefully this creates a random number of. It's not that random, but there we go. Is that going to? Oh, there we go. Yeah, it's random. Oh, cool. That's quite cool. Now we can. We get a bit of animation now. There we go. So it's just randomly generating the size of the circle each time we evaluate. And we've got an image here. It's just helping us explain some of that as well. And we can do okay, that's quite nice. We can do opacity, so how much of the color is actually showing through, so we can show that's interesting. Oh, so that's an O. Okay, right. So we start off with opacity 0. I'm not sure why they put. Oh, I suppose, yeah. And it's interesting. It's using ratios in here. That's interesting. So when we got opacity 0, then obviously it's not showing through. So it's just completely transparent. It's showing through. It's basically showing through the background color that this is on. So that's why it appears, I guess, grayish. And then these are quarter versions and half versions of the color black, because it seems that black is the default color here. Okay, there we go. So that's an interesting way to introduce a function definition and help them understand that as well. Yeah, so that's another example. Cool. So I might break this up into different pages so that it's a bit easier to, because this is quite a long document. But we'll see how it works. Let's see, what does that do? Okay. So it's showing you, I guess what is kind of showing you like the basics of what kind of thing this is again. So again, it's telling you that this is a function, just like square is a function, except you're actually seeing the details. You're actually seeing the basic algorithm underneath saying the basic algorithm underneath the function, because it's right there as a definition right in front of us. So I guess it allow people to kind of understand how to write their own functions, which I think we're starting to come on now. Yeah, so I think the example is to go and do that as well. So that's quite nice. And then we do names. So giving names to things that we're doing. Oh yeah, so we're using let. So we're creating local names. So rather than using def, we're just using the let function. So let function is binding a name of t. It's not the best name, but there we go. And it's saying that t is going to represent a triangle of 100. Next, so we're going to create a layer from my triangle, and it's going to and we're going to so just basically going to create a bunch of triangles in different positions. What did I do now? What did I break? Oh yes. Yeah, we need to specify that in there. So was that T? The layer is the same name as interesting. Let's put that back to T for a second, because otherwise I have to change everything. Oh, there we go. So we get, oh, that's interesting. So we can create a little mountain range. If you put little, I guess if you positioned it right, you could put little white triangles at the top there, and you create a nice little mountain range. You create the Himalayas or something like that. So that'd be quite nice. And maybe have little, I wonder if there's stars, or maybe you have to make your own star, and you can have, you'd have those as white pieces of snow. That'd be quite cool. Let's put that down. Range. Yeah, I'm not sure if it, yeah. I'll have to look into layer a little bit more to see why. Okay, so layer takes, okay. And there's layered over each other. Okay, fair enough. Oh, yeah, and it's also talking about def. Oh, yes, okay. So we can use def as well. That's good. So if we want to, yeah, so obviously the let is just going to be within the scope of these two brackets. And so once we are past this bracket, then T no longer exists. But if we wanted to define a rainbow, oh, there we go, or rainbow colors, then we can just evaluate that, and then we can go off and use that in another code block somewhere. So, oh, that's pretty. So yeah, so we can, once we've defined something, then we can use that throughout the page as well. So that's quite nice. And then, oh, we get down to 44. What else have we got? So I'm going to skip through this because I want to show basically how to get into GitHub as well. So I'm going to go through this and see what other things we're doing, but we're also doing applies and as well as map. So applies is pretty much kind of like reduce. It's slightly different, but the same kind of intent. So basically going over, well, let's see what it's doing. Doing an awful lot in there. There we go. Okay. So we're doing two rectangles, one above the other. So the above, yeah, I guess is putting. So we're not using position now. We're actually implementing a way to kind of draw one. Excuse me. Sneeze. So we're now we're just using one color to draw. Using apply to draw one color above another, one shape above another. And so there we go. We can do, oh, cool, we can do flags of different nations. That's quite cool. And the Spanish Catalonian flag. Oh, I'm not sure if that's entirely accurate, but there we go. And that's what they've got so far. So there is a duplicate. I'm going to see if this works, but no, it's still not working. So you could duplicate this, but for some reason this isn't working on my machine for some reason. But you can go in, if you click on the this menu, you can show that there's like the recent curriculums you looked at, so the recent pages you've looked at. But it's also got your, if you've got a GitHub account, it will show you the relevant gists that are that you have. So we're going to have a look at that and show you how to create that. Because you can also go off and create a new curriculum here as well. So like that. And then you can go off and do some code in here as well. You still got, I think you still got circle. You still got all the default functions that come with Maria.cloud. And so, like, yeah, pretty much all the. So you can do some more advanced things inside Maria.cloud as well very easily. And you can go off and can we? That's okay. If we save that, we can go save that, and then that's saved it to. Has that saved it to the? Yeah, so that saved it to my GitHub gists because I'm already logged in. If you've got this sign, then you're already logged in. So let's have a look at that. So if we go to gist.github, so gist.github.com, and so instead of so normally with GitHub you've got all your Clojure repositories, which is where you put your projects. And so you've got a full kind of project that's all version controlled. If you just want something simpler, then we've got something called gist or gist. And you can just basically put in a single file in there, or just if you want to add some notes in there, it's quite useful. And I've got a whole bunch of gists already. And you can see here that this is one that's just been answered. So by default, it's creating a secret gist or gist. I'm going to call it gist. Well, it's me. That only I can see, but I can go in and edit that if I want. I can go in and make that public, I guess. Oh, maybe I can't. Oh yeah, make public. Yeah, so make that public so anybody can see that as well. And I can go in, edit that, and you can see the raw code of it as well. I've made it public, and then go and edit it, and I can just go in and add code in here. So I could do and what you can see is that the actual text that appears in Maria.cloud is, oops, that's not the right one. I've lost it now. There it is. So this is just text, and there is no there's no code yet. So the text shows up there normally, but underneath this is a Clojure script file. So it is just showing. Sorry, it is just showing. So if you want to put in just text, you just put that as a normal Clojure comment, and then code you just put in as normal Clojure, so in brackets. And if I update that, so I can save it. So you could actually write your gist in here or in some other editor as well. So you don't have to write it in Maria.cloud. And then if I update this, if I reload this, it'll load the gist in. I think I might need to log in and log out for it to get it to do that. Here's one I did earlier, I think. Yeah, so I just dumped some functions. Oh, but I've dumped some results of some functions in there. Yeah, it seems to cache it, I think, if you don't log it. So you need to, if you do edit the gist directly, you'll need to kind of log out and log back into Maria.cloud for it to update. And but then it should work quite normally. There we go. So that's another one we've got where I've got some code in here. Yeah. So let's, if I go to, oh, that's what I started doing, but that's in, what was that? Okay, the previous one. So if I go to GitHub, actually actually. Where is it? So if we go back to Maria.cloud, boom, boom, boom. There we go, home. There we go. So if you go and look at the, if we go to bug reports, actually that'll take us where I want to go. This will take us to the GitHub project in here. So there's some active work going on to this. There's a few issues to resolve as well, but it's still kind of being updated, which is good to see. But we can also go in here and look in the curriculum. And there is the learning Clojure with shapes. So this is the CLJS thing here. So I could actually just select, you can see here, we've got the text, just the normal text is just Clojure comments, just the single quotes, and circle is just normal code. And so you can just basically write that fairly easily in whatever editor you wanted to. If I go in and select, well, actually, let's get the raw version of that. So we can just copy, select all, copy, there we go. And I'm going to go back to my gists. I think if we go back to JRocket, GitHub gists, and I'm going to create a new gist, and I'm going to call it ClojureBridge. And then if I do, and I believe you need to do it for CLJS. This is a file name, so let's kind of put it all. A nice file name. Okay. Maria. And then so for ClojureBridge. And I'm going to make this public because I want everybody else to see it. And the advantage of making it public is if you go to, well, if I just go to anybody's GitHub gist, if I want to see all gists, there we go. You can go off and go to somebody else, and you can go off and fork somebody else's gist into yours. So you can go off and create. So if I did a search for Clojure script, then I can go off and fork somebody else's thing here. And nobody's forked it yet. If I go and click on the page, I can go and fork it and basically make a copy of their code, and it goes into my gists. So if I go back to, so now it's in my gists. So I've got a copy of that. So what we're probably going to get the students to do is to go to this page, and they will be able to go off. They'll have a fork button here, and they'll be able to just do that. And when they come back to Maria.cloud, they should just be able to sign in with GitHub here, and should automatically fill that in for me. There we go. And now when they go to here, it'll be like their account name gists, and they'll be able to go on here and select. Is that not updated? You should be able to select that from here. It only does selected ones, so I'm not quite sure which ones it's doing, but I'll have to look into that. Obviously, it's not picked up the the ones I wanted. There we go. Let's get rid of these. That's interesting. I'm not sure why it's not there, but I shall go and have a look at that, see if we can figure out why that's not happening. Because it is on there as well. I'm going to get rid of the other one. Yeah, I don't want this. So I can just go in and delete that, tidy that one away. That was just the one I forked from somebody else. It's picking up that one. Did I see CLJS? How bizarre. I'll go and see if I can figure out why it is, but that's kind of the approach that we're going to try and take. And now I can go in and I should be able to go in. Even if I go into my editor, I can go in. And Spacemax has a nice tool for going in and looking at my gists. I do space GG, GitHub gists. I can go and list my gists, and that's not even updated. Oh, that's interesting. That should pull up the latest version. Oh, maybe GitHub takes a few minutes to update its gist list, or I'm not updating the gist list properly. That's very weird. Okay. Hope so. No, it's not there. Interesting. Something else to look at. So I'm not quite sure why it's not picking up. That's unless it doesn't like the dashes. Because it's picking that one up. Maybe it doesn't like the dashes. Let me just edit the file name. Let's see if it's something. That's Maria.cloud. Unless it only does secret ones, but I'm pretty sure it does public ones as well. Let's just go back to there a second. Where's that one? No, because that's public. That one's showing up. But that's interesting. Software worked all the time, then we wouldn't need software developers, would we? I think that's updating, but let's go back to Maria.cloud and see if that works. If not, I'm just going to leave it here and I'll go and try and figure out why it's not picking this up. And put some notes in the. Oh, we've got 14. So it's picked up another gist. So that's more. Oh, there we go. Yeah. That's interesting. So there, for some reason, there's certain. We'll have to experiment with the name of the file because it wasn't picking up, unless it's just purely a timing thing. I click on that, then hey, there we go. So I've got the Maria.cloud curriculum put into, which is on my gist now, so I can edit. So all the changes I make are going to appear on that gist, or should do. Let me just double check that. Let's make a simple edit change. Let's change this to, oops. Ooh. How did I do it? Oh, my mouse got carried away. There we go. And then, so there's a save button. So there we go. And then let me go in and. Oh, there we go. So yeah, so that's changed it. Yeah. So that's working. So we've got this welcome to ClojureBridge is now changed because we changed it in that. So whenever we're going in and saving Maria.cloud, then yeah, it's updating our gist. So we can always come back here, and even if we mess up and we don't save, we could just reload and it will pull in the updated gist for us as well, the existing gist. Cool. Alrighty. And is it working in SpaceMax? I'm going to have to see why it's not working in SpaceMax. There we go. Interesting. Okay, we won't worry about that for now. There we go. So this was Maria.cloud, and this was yeah. I think it's a really nice way to go in and interact and help people interact with Clojure and have that conversation with their computer, and give very nice yeah, visual feedback that they can kind of is nice and easy to understand. And we can just basically go in and edit our code in either a GIST or in Maria.cloud. It does seem to be it's probably easier to do that in Maria.cloud directly, and save them and save all our changes. And so I'll create a ClojureBridge version of the curriculum. Just make sure that we've got everything that we want to include in there, and maybe create different sections. So it might be just like a basic introduction, and then using functions with functions and so on and so on. We'll see how it goes, see how much we want to break this into different pieces. And if we want to create a different page, then again, it's just a new gist, a new gist in here. We'll just create a number of those ones. I'll probably move them to the ClojureBridge account at some point as well once I've finished developing them. But that's all looks like it's working enough for what we need. Okay, if you have any suggestions, then feel free to come and yeah, play around with my Maria.cloud ClojureBridge file. I'll put the link in there in the notes of the video. And if you have any suggestions about what we should include, things, exercises we can get students to do, please let us know, and we'll include them. Thank you very much for listening, and I will see you again next weekend. Thank you. Bye-bye. Bye-bye.